Hi, in this video, I'll be showing you how to graph a function, right? So, the fundamental function that all of you should know is the straight line function. The straight line function, which is represented by this equation y is equals to mx plus b, right? Where your m is the gradient. So most of you guys will want to know what is a gradient. So let's say you are given a function like this, right? A function like, let's say it's a straight line. So a gradient is sort of the steepness of a function. A gradient is the steepness of the function. So the higher the gradient, the steeper the function. So if this function is like this, compared to a function that is like, let's say like this. So which one has a great, what is this? A greater gradient. So this function will have a greater gradient. Why? Because of its steepness, right? Compared to this one. Okay, let me erase this and show you how to plot a straight line function. So I'm gonna make examples, right? So remember, we must stay in touch with this equation, right? So let's say you're given y is equals to 2x plus 3, right? So y is equals to 2x plus 3. Let's say they asked you to plot your function. So there are several ways to plot a function, but I'm going to teach you a method of which you can use in plotting all kinds of functions, not just the straight line function, but all kinds of functions. So this method is pretty easy. You can just say you can do a graph like sort of a table like this. You can do a table like this, and this side is your x coordinates and y coordinate, right? Yes. So in this case, when plotting this function, you have to estimate. What I mean is that you all know we have what we call a domain and a range, all those things, right? So let's say you have your Cartesian plane. I know all of you know how to draw this, right? So we have our origin, we have let's say our -1, our -2, we have our 1, our 2, our 1, our 2, -1, -2, right? So we have our x-axis, we have our y-axis, right? So we are required to plot this function. The question is, how can we plot this function? Let's say we substitute -1 into this function, right? Let's say I substitute -1, right? So we are estimating that for our x coordinate, we have -1. We are estimating based on the Cartesian plane. So let's say this is my original function that is given. Then I take this x coordinate, I substitute it here, -1, to get my y coordinate, right? So let's say it's y is equals to 2 times -1 plus 3. So we already know that 2 times -1 is -2 plus 3, which is going to give us 1, right? Then we do the very same thing. Remember that these numbers start from -1 goes to 0 to 1, right? This is the mathematical sequence of these numbers. So we can say, and then the next we can say our x is 0. And then here we substitute 0. What do we get? 2 times 0 is 0 plus 3. We get our coordinate, which is 3. And then 1. Yeah, here we estimate to have 1 as our x coordinate, and then therefore we have to put 1 here. So 2 times 1 plus it's 5. Okay, meaning that we have to extend our Cartesian plane. So let me just do this so that I can extend my Cartesian plane. Okay, cool. Let me just erase this one so that I can throw a bigger one to feed all these coordinates. This thing is pretty easy, guys. You just have to like um know the steps, know the steps. Even if you get to an exam, just know uh those steps. So we have our 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. This thing is not accurate, obviously, but when you're writing your exam, you're gonna use a ruler uh for the matter of accuracy. Okay, so okay, this is our Cartesian plane. So the first coordinate that we have is -1 and 1. So we have a -1 at x, right? -1 at x and 1 at what? At y. So our coordinate, let me change color. So our coordinate is gonna be here. Okay, so our next coordinate is 0 and 3. So meaning our x is 0, our y is 3. So our x is 0, our y is 3. So 1, 2, our x is 0, our y is 3. Okay, it's gonna be somewhere here. Okay, cool. So our next coordinate is 1 and 5. So 1 and 5 here. Our x is 1, here's 1, yeah. Then our y is 5. So it's gonna be 1, 5. So yes, so there is our thing, our straight line graph, and then you are done. So basically, plotting a function. This is our straight line function. So basically, plotting a function on an exam is probably 4 marks. So you get your 4 marks. So you're gonna get your 4 marks based on whatever function that of true. So let's do another example based on this. Okay, let me just do this. Let's do our next example, right? So let's say you are given let's say you are given y. Let's say you are given y is equals to 3 over 4 plus 2. Remember one thing, guys. Okay, I'm sorry about this. 3 over 2x. Remember one thing, guys, when I was emphasizing when I started this video that m, based on this equation, m is our gradient, is the gradient of our straight line, right? So this is what we are given here. Remember, this was the first example. This is the second one. Let me just do this. Okay, sorry. Okay, cool. Okay, cool. Yeah. So remember, this is the gradient of our graph, right? So let's do it again. So first thing that we have to do is the table x, y. Okay, let's make it quick. -1. So here you have to substitute what? -1. So now we're moving because I've already emphasized the thing. -1. Then put it in the calculator. 3 over 4 plus 2. 3 over 4 plus 2. Okay, so our -3 over 4 plus 2 gives us 5 over 4, which is approximately 1,25, right? So okay, let's make our x coordinate to be 0. So if you substitute 0 here, 3 over 4 times 0 is gonna be 0 plus 2. So here we're gonna have 2, then 1. So if you substitute 1 here, it's gonna be 3 over 4 plus 2, which is gonna be 11 over 4, which is gonna be 2,73. So we have our coordinates now. So let's plot our graph, right? Cartesian plane, remember, very important. Cartesian plane. Okay. 1 2 3 1 1 2 3 1 2 3 1 2 3. Okay. Okay, cool. So we have I'm sorry, my points are not as exact. 1 2 3 -1 -2 -3. So I'm trying to sort of make you understand the importance of plotting the functions, because I think it's probably 21 marks or like 24 marks um, in your question paper. So if you're writing out of 150 already, you have approximately 29% or 28%. Yeah. Okay, so let's plot our graph. So for the first function, for the first one, coordinates is -1 and 1,25. So -1 for x and 1,25 obviously is gonna be somewhere here. It's gonna be somewhere here. So it's gonna be okay, cool. Sorry. Yes, so it's gonna be somewhere here. So it's gonna be -1, our x coordinate, and we're gonna have 1,25 for our y. So it's gonna be somewhere here. Okay, cool. So for our second one, it's 0 and 2. So 0 for x and 2 for y. And our third coordinate is going to be 1 for x and 2,73 for y. So 2,73 is going to be approximately here, and 1 for x is going to be somewhere here, right? Yeah. So this is gonna be our graph. So it's gonna be connect all the dots. So yes, connect all the dots. This is our straight line. Let me just use a different color. Let me just use a different color. Yeah, this is gonna be our straight line graph. Yes. So this is gonna be our straight line graph. So you see we have these 3 points. Let me show you. We have this one. Yes, we have this one. We have this one. We have this one. This is easy because I've plotted all these points using this and the original function. So remember the step. First step, make your table. Your estimated x coordinate is gonna be -1 0 1. So -1 0 1. Next thing, take this thing, substitute into the original expression, then get your y coordinates, then take those coordinates, plot them, connect them, and then you're done. You get your full marks.